Hello, this is Mrs. Bentley, and I'm here to go over rate of change with functions. So if you look, the first thing we're going to take a look at is the definition of rate of change. A rate of change is a rate that describes how one quantity changes in relation to another quantity. We can also refer to rate of change as a ratio. Notice on top in the ratio we have the change in y. So we need to find the amount that our y, which is our dependent variable, is changing, and we're always going to write that over the change in x, and x is always going to be that independent variable, or the domain. Now, if we have 2 points in the form of ordered pairs, we can also use our formula. This should look familiar. This is also the formula we use to find slope. So to find the change in y, we can take the y2 coordinate, subtract the y1 coordinate, and write this as a ratio over the x2 coordinate minus the x1 coordinate. So we're going to take and actually find the rate of change of different functions. They're not all going to be linear. Some are going to be, in this case, this first one is exponential, but we're still going to always use this formula. So if you look at example 1, it says we have an exponential function. It is represented in a table this time. So we're going to look at different types of representations. What is the average rate of change of the function from x equals 2 to x equals 4? So we are going to look at the ordered pair where x equals 2, and that is the ordered pair 225. And we're going to look at the ordered pair when x equals 4. That's going to be the ordered pair for 625. Now, when it's in a table, you can really just look at the change. So we're looking at the change from 2 to 4. And if you think about what the change from 2 to 4 is, that is an increase of 2. Now, if you look at the 2 numbers I have circled under f of x, which is also our y, the change is going from 25 up to 625. So that is a change of 600. We're adding 600. Now remember the ratio. We need the change in y over the change in x. So we would take the 600, that's your change in y, and then we're going to write this over the change in x. And in our table, when we look from 2 to 4, we're skipping the 3. From 2 to 4, that's an increase of positive 2. Right now, our ratio is 600 over 2. You always want to always simplify your ratios when possible. So check to see, can we divide 600 by 2? And yes, we can. So the average rate of change for this function is 300. Another way to have done this problem is you could pull these ordered pairs out from your table. We have the ordered pair 225, and we're looking at the change to 625. Remember, we have the formula. Your first ordered pair is considered your x1, your y1. Your second ordered pair is your x2 and your y2. The formula tells you, I'm just going to refer to that as m because slope and rate of change are calculated the same way. The slope is to take y2, that's 625, subtract y1, 25, and then we're going to write this over the change in x. You're going to take the second x coordinate and subtract the first x coordinate. 625 minus 25 simplifies to 600, and 4 minus 2 simplifies to 2. Again, simplify that fraction. We can divide 600 by 2. We get an average rate of change of 300. So you can use your formula, or in a table you can easily just look at the change, look for the pattern. Okay, in example 2, we're going to actually look at the function represented on the graph. It says, consider the function shown in the graph. What is the average rate of change of the function from x equals negative 5 to x equals 7? So on the graph, on our x-axis, we need to go left to negative 5, 1, 2, 3, 4, 5. Follow this up to your function. This is the point. Over on the y-axis, it has a y-coordinate of 4. So this could be written as the ordered pair negative 5, 4. We are looking at the average rate of change from x equals negative 5 to x equals 7. So now we need to go right 1, 2, 3, 4, 5, 6, 7. and up 1, 2, 3, 4, 5. So this ordered pair is located at 7, 5. Now notice we have formed two ordered pairs. We have an x1 coordinate, a y1 coordinate, an x2 coordinate, a y2 coordinate. Again, we can use our formula to find the slope or rate of change. You take the second y coordinate, 5, and you subtract the first y coordinate, 4. And now we're looking at the x's. We're going to take the second x coordinate, 7, and we are going to subtract the first x coordinate. Be careful here, this is a negative 5. 5 minus 4 simplifies to positive 1. And with our integer rules, when you subtract a negative, this becomes plus a positive. So 7 plus 5 simplifies to 12. So the average rate of change is 1 over 12. Now we could also count the rate of change on the graph. We've marked the 2 points. I've used the 2 blue dots. I can count the rise over the run to those 2 points. You don't have to worry about following the actual graph line. From this point, we're going to go up 1. So that's our rise, 1. That number goes on top in your ratio. Notice we have 1. And then from this corner, you're going to count how many units we need to move over to get to the other blue point. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our rise was 1, our run was 12, so our average rate of change is 1 over 12. Okay, in the third example, we're going to look at a function as an equation. So notice we are given the function f of x equals 1/2 x minus 7. Remember, your x is your input, and when we substitute the number in for x, we get an output. That's going to give us an ordered pair. So the first value we're going to substitute is the x equals 2. So we're going to say f of 2 equals 1/2 times 2 minus 7. Half of 2 is 1, and 1 minus 7 simplifies to negative 6. So the input was 2, the output was negative 6. We now have one of our points, or one of our ordered pairs. Okay, the next one, we're going to use the value x equals 10. So we're evaluating the function for f of 10. It tells us to take half of 10 and subtract 7. Half of 10 is 5, and 5 minus 7 simplifies to negative 2. Our input was positive 10. Our output was negative 2. We're now looking at that rate of change. We're wanting to see how much did this change when we went from x equaling 2 to x equaling 10. So I'm going to use that slope formula. This is my x1, my y1, my x2, my y2. So our formula is to take the second y coordinate, negative 2. We're going to subtract negative 6. Be careful here. This is going to become plus positive 6. And now we're going to take our x2, 10, and we are subtracting 2. Now we're just going to simplify as much as we can. Negative 2 plus 6, that simplifies to positive 4, and 10 minus 2 will simplify to 8. 4 over 8 reduces to 1 over 2, 1/2. So your average rate of change for this function is 1/2. Okay, example 4, we're going to take one more look at a graph. Notice it asks us to find the average rate of change of the function from x equals 1 to x equals 3. So you want to go over on the x-axis to positive 1 and follow this up to the point. This point is located at 110. Okay, we're looking at the average rate of change when x equals 3. So we're going to follow the x-axis over to positive 3. Follow this up to your point on the function. This point is located at 340. Now we can either use our formula, we have two ordered pairs, or we can count rise over run. You must be careful on counting rise over run because notice that your y-axis is counting by fives. So each move is going to count 5. So from this first point, right here, I'm going to darken it in green, we're going to go up. There's 5, 10, 15, 20, 25, 30. So my rise is 30. Remember that number goes on the top in the fraction. Now to get to the right where the blue dot is located, look on your x-axis. Your x-axis, the interval is only counting by ones. So this is 1, 2. So your run is positive 2. So our average rate of change is 30 over 2, and this simplifies to positive 15. I'm going to also show you how you could use your formula. So if you wanted to use the formula instead, we have the points 1, 10, and 3, 40. Remember the first coordinate in the first ordered pair is an x, so we call that x1, y1, x2, y2. To find change, we always subtract, so we take the latest number, the y2, and we subtract the y1. So 40 minus 10 over 3 minus 1. 40 minus 10 simplifies to 30, and 3 minus 1 simplifies to positive 2. We can divide 30 by 2, so this simplifies to positive 15. So the average rate of change of this function is positive 15. Okay, if you flip over on the back, you're going to see 4 practice problems for you to try on your own, and you also will receive your study guide for this unit test. That will give you the weekend to work on your study guide. On Monday, we will have a test review day, and next Tuesday, you will take the Unit 1A test. I'm sorry, that's the Unit 1B test.